Hello, everybody. I want to go over another problem that I found on LeetCode, and this was searching for the maximum depth of a tree. Um, so yeah, let's get started. Took me quite a while for me to understand how exactly to do this, but I finally figured it out. So I'm just gonna do it how LeetCode wants it. So, how can I spell? Shun. Sorry. I'm not an English major, so um, don't really know how to spell. Um, so we're going to say public, and then we want it to be an integer. We want it to return an integer, so we're going to say int max depth. Call it max depth, and we're going to be passing a tree node pointer root. And this is all the same code that I've been using for all my tree videos. Um, I think I took away print in order. Oh no, I still have it. Um, but yeah, this is same code I've been using always. Um, so yeah, in here, in this um in this method right here, we're going to want to uh return if a root is null. If we reach the end of a root, so here, so like for example here, 0. If we reach null right here, null right here, we're going to want to return 0 for both of these two right here, these two left and right nodes. So we're going to say if root equals null pointer return 0. This is our base case. And then we're going to want to say int left depth uh, is equal to, and then recursively call max depth on root left. And then same with right depth is equal to max depth, sorry, root right. Oh, RIGHT. And we are going to want to return std max, which is going to choose whatever the max is from the left or right depth. So left depth and right depth plus 1. And this is to calculate the position of the current node. Um, so yeah, this is essentially it um, that we need for our max depth. And I'm going to go over how exactly it is working. Like I said, it took me a while for me to understand, but uh, oh, I finally got it. So I did get me a little hinting um, pad, so I'm trying it out the first time in this video. So sorry if I'm messing up a bit. I've been using my mouse to draw, and I was getting a bit tired of it. So yeah. I'm just trying to. Okay. So here, if we compare, if we start off with this root right here, of 5, we would be recursively calling all the way down till here, all the way down until we reach no more left nodes. So call the left of 5, which is 3. Check if 3 has a left. It does. It's 2. Check if 2 has a left. It does. Check if 1 has a left. It does. Check if 0 has a left. In this case, it doesn't. We enter our base case right here. So we know that left um, for 0 is going to be 0. Sorry, this pen is pissing me off. It's my first time, sorry. Now that we've checked the left side of 0, we can come back to here and then check the right side of 0. In this case, we have a null. We reach the base case again, right here, we would return 0. Let me just fix this right here. 0, comma 0, which is the left depth and the right depth. So now that we've checked um, if this 0 has any nodes in it, we would return max of left depth and right depth, which is what I'm doing right here, representing this stuff right here. So 0, comma 0 plus 1. I honestly think I was doing better with the mouse. I'm gonna give it a little bit more practice. Give me a sec. I'm gonna just use my mouse. So 0, comma 0 plus 1. We return this to be the depth of 0. And this is kind of this recursion is kind of working backwards. It's starting from here instead of calculating from like 1, 2, 3, 4, 5. So I'm gonna be kind of talking backwards. But yeah. So we return the depth of this to be 1. So this is equal to 1. We return the max of either left or right. In this case, both left and right are 0. We're in this part right here. Plus 1 is 1. We know that 0 will be a depth of 1. Now we have checked the left side of 1. We can come back to 1. We will now check the right side of 1. In this case, we have 0. There's nothing here to check. We return 0. Now to calculate the depth of 1 right here, we would be returning this part again, but we already know that to the left of 1, there's at least one node here, which is 0. We would be returning 1, comma 0 plus 1. This is going to give us the calculation or like the depth of 1, which gives us 2. Now we have recursively checked the left side of 2, which is because of this part. Now we will be recursively checking the right side of 2. In this case, it is null. We enter this part again. Now that we've entered this part, we can now return the depth of 2. Remember, this is 2 right here. Now the depth of 2 would be, like I said right here, the depth of 2 we would be returning 2, comma 0 plus 1. The depth of 2 would be 3 now. Ew, what an ugly 3. 3. Now that we've checked the left side of 3, we can now check the right side of 3. In this case, and it kind of like resets what I noticed from doing this example. And I'm gonna show you that in a bit. So once we check here, we can see that we have a right of 3. Now we recursively check, since this is our new root node, we will recursively check the left side. It is null. We would return, and I'm gonna do this as like a little subset right here. So this is to the left, currently left. Sorry, I'm gonna just say left as L, left of 3. We've had these calculations. To the right of 3, right of 3. Right of 3, we have here. Now to the left of 4, we have null, which is 0. We come back to here. We know that, sorry, this is 0. Now we check the right side of 4. This is 0 as well. We return how we did here for 0. For this 0, we return the same thing right here. The depth of this is 1. Now that we have checked the depth of these two, we can now compare what the depth of 3 will be with the depth of all the left of 3 and all the right of 3. We would be returning 3, comma 1 plus 1, right? Because we already checked the right side of 3. Now we want to return what the depth is. What the depth is, we would be returning the max of the left, whatever left or right is. In this case, the max is left side. So we would return 3 plus 1, which is 4. We know that this is 4. Now, before we check the depth of 5, since we've already calculated all of this, now we enter this side right here. But for 5, we recursively check the right side of 5 now. So now we're at 6. 6 is our new root. It's not a null. We don't return 0. Now we check the of left of 6. In this case, it is a null, so we return 0 for this guy. But before doing so, we now will calculate what we know that there's 0 nodes to the left of 6. Now we check the right of 6. We have a 9. 9 is our new node. We check the left of 8. 8 is our new node. We check the left of 7. Of 8, it's 7. 7 is our new node. We check the left of 7. We reach null, our base case again. Now we check the right of 7. We reach null again. We entered this part, but we reach null again. So for 7, we will now do how we did for 0 right here and 4 right here. We would return 0, comma 0, since left of 7, there's nothing here. Like we said here, we're returning 0, right? We're returning 0 as well. Plus 1 equals 1. We know that the depth of 7 is at least 1. Now that we've checked the depth of 7, we can check the right side of 8. In this case, it is null. Now, to return the depth of 8, we would say, we know that the left of 8, there's at least 1 node. There's no nodes to the right of 8. Return 0 plus 1 equals 2. This is the depth of 8. Now we have calculated how many nodes are to the left of 9. We can now check the right of 9. So we move on to 11. 11 has left nodes. Check the left of 11, it's 10. Check the left of 10, no nodes. No nodes, so we return 0. No nodes to the right again, we return 0. Like we did for 7, we will return something like this here. So we know that this is also 1. Now we've checked all the left side of 11. We checked the right side of 11. Like we did with 10 and 7 and 0 and 4, we will return 0, comma 0 plus 1. This is a depth of 1. Now we have recursively checked all the nodes on the left and right side of 11. Now, to calculate the depth of 11, we would return 1, comma 1, which is, this is what we're doing right here, 1, comma 1 plus 1, which gives us the depth of 11. We would pick whatever the highest one is in between these two. In this case, I'm gonna just say the right side, 2. Now we know how many nodes, how deep the nodes are from the left and right side of 9. Now to calculate 9's depth, we would be returning whatever the depth of their left nodes are. In this case, we would be returning 2, comma 2 plus 1. So now we know we would pick whatever the highest one is here. For 9, doesn't really matter because they're both even. They're both the same. I mean, this is 3. Now we know that the depth of 9 is 3. Now back to 6. We know that to the left of 6, there is 0 nodes. 0 nodes. We would return 0 for left, because this is what we have right here, left, comma. We know that there's 3 nodes to the right of 6 because of this, because of the 9, the depth of 9. 3 for the right. plus 1. And to get the height of 6, we return the max of whatever left and right is. In this case, right is the largest one, which is 3. 4. We would be returning 4 here, which is the depth of 6. Now we have calculated the depth of all the nodes to the left of 5 and all the nodes to the right of 5. Sorry, this looks like a 9. 4. And we have calculated to be 4 down here and 4 down here, right? 4 deep here and 4 deep here. So now to calculate the depth of 5, we would say 4, comma 4 plus 1. So for this, we've already searched all of the left side, and we've already searched all of the right side of 5. Now we would finally return 4, comma 4 plus 1, which equals 5. So this is 5. Now we know that this is how deep, or this is the deepest number of nodes this tree goes down. And we can see right here, if we zoom in, starting from the root node, we would have 1, 2, 3, 4, 5. Let me just circle that. 1, 2, 3, 4, 5. And if we go to the right of 5, we'd have 1, 2, oh, missed the 6, 2, 3, 4, 5, or 1, 2, 3, 4, 5 right here, or 1, 2, 3, 4, 5. So in this case, it is 5 all around. So yes, now to put it in here, let's just print out, we'd say int max depth is equal to, and then how LeetCode does it is this is how they do it. So that's how I'm doing it. Solution is, so we say int max depth is equal to solution dot max depth tree dot get root. So it would get the root 5. SED cout max depth of tree max depth and L and line. If we run it, uh-oh, sorry, let me run it again. Here we go. Original tree. This is how it looks like. Max depth of 5, just like I showed y'all. Hopefully this explanation, y'all understood it. Like I said, it took me a while to understand, and I didn't figure it out until like just an hour ago. Yeah, just I had to draw help many times. But yeah, let me know if y'all understood or if you need more clarifying questions. I'd be more than glad to help you guys or just make another video about it.